If you allow, I can continue. Next speech is our common research with academician Sergey Goncharov, with my teacher. We made some important, for my opinion, results, which help us to create some methodology for some approaches, continue some approaches, which I will show right now. And we try to implement this in real applications, and I will show some tasks, and I will show some tasks where we realize this. И нужно включить презентацию. Just a minute. These questions about how we will continue our approaches in artificial intelligence, where we propose use our mathematics, our Russian mathematics in this direction for artificial intelligence development. Okay. Okay. Okay, I will be short because we have not sufficient time. Our title is Task Approach and Trustworthy AI, New Prospects. How we see our development in future in AI directions. First of all, I would like to present our team, Siberian team, Logical School of Artificial Intelligence. How I said before, we can use Russian mathematics, and all of these people's researchers use Soviet mathematics, which we improve for real world. We use a logical, we use a probability, we use a learning theory and semantic programming. Our team, it's heads. It's two academicians, Yuri Leonidovich Yershov and Sergey Sevastianovich Goncharov. Many professors, it's Sviridenko, Vityaev, Palchunov, Mantsevada. Many doctors, Kolonin, Pavlovsky, me, etc., etc. We developed right now this direction, and we believe that we help to increase capabilities of artificial intelligence, combining large languages model with our logical probability approaches. Right now, we work in Artificial Intelligence Center of Novosibirsk State University. On the one important task, it's need to generate, developed platform, which will be create a new AI-driven digital twins for smart cities, because we win a grant on this, and we have some tasks, many devices, billions devices, many peoples, many driverless car, and etc., etc. Many big data, very big amount of big data. We need to analyze this big data. We need to create a new knowledge based on this data. We need to use artificial intelligence algorithm also. And right now we work on the next direction. We will store all this data, and we have two real ways. First way is it's resharing data, where when we share our data on the computers, it's Joshua Huang presented all methods before. It's a random sample partition method, and etc., etc. But we think right now it's a good way. It's use blockchains, because blockchains right now it's very fastly growth direction. Not only cryptocurrencies use this technology. I think it's a future for using for storing big data and execute programs, because on blockchains we can create a smart contracts, we can execute any programs. We can store a large languages model. We can store a data set for this languages model, and it's a transparent, immutability, reliable, and our idea is use a multi-blockchain. I get this idea from white paper of Nikolai Durov. It's a brother of Pavel Durov, yeah. Sorry. Yes, it's a brother. He is a mathematician, PhD. He has won a gold prize of medal on mathematical Olympiads. Also, he won gold medal in program Olympiads. And his idea was to create a multi-blockchain structure. When we stored some information on low-level blockchains, but then using a hash function, we send some information on top-level blockchains, concentrate hash from this low-level blockchains. On top-level blockchains, it's most securable, most centralizable blockchain, which stored all structure of this multi-blockchain. And key challenges right now in build trustworthy AI, if we can consider, first of all, guaranteed temporal accuracy, ensuring that AI system operate within predictable time constraints to maintain reliability, formalize decision-making processes implementing comprehensive formalization and oversight of AI decision-making to enhance transparency, correctness. Adaptive learning capabilities, facilitating the continuous learning and self-improvement of AI system to adapt to evolving environment and requirements. Storage and processing of large volumes of information. First of all, I want to say that on one of these challenges we have our solutions, and I show you in the next slides. To achieve this object, the following mathematical and methodological frameworks are considered. Task approach. This approach emphasizes the formalization and classification of task environments and their parameters using formal logical spectrum. It's semantic programming. This concept allows us to correctly implement formalized tasks and find their solutions. And we guarantee a polynomial computation complexity in this direction because we have some mathematical theorem. Blockchain and multi-blockchain for stored information because we need to analyze all information. Multi-agent system agents allow to link together all processes securing a smart city, virtual city, and metaverse, the action of which are coordinated through a multi-blockchain system. Okay, and concepts for trustworthy AI, building upon these approaches, several important concepts can be developed. We developed a theory of learning intelligence systems. It's a first. We developed a programming methodology, including complete languages, and developed some approaches for hybrid artificial intelligence construction. First of all, theory of learning, it's a theory based on logical probability aspects. We use this with learning capabilities of large languages model for guarantee correctness and reliable final solution which a large languages model can give. And we use this in many applications right now. It's right now we developed some concepts. It's a metaverse development. It's a reliable AI-driven system for smart city management and has civic participation in urban governments leveraging. In all of this application, we use a combination AI technologies and multi-blockchains because multi-blockchains can be a global memory for any intellectual agents, for any intellectual systems. Because it's transparent, because it's reliable and immutable. Because our topic is a task approach and trustworthy AI, I would like to present our secret weapon, mathematical secret weapon, for increasing intellectual capabilities of intelligent systems it's a task approach. When we formalize our task using a logical formulas, and these researchers, these high top-level researchers, Russian mathematician researchers, from Kolmogorov, Altshuler, academician Yershov, Professor Samokhvalov, academician Goncharov, Professor Svetyaev, and Sviridenko, it's a pioneers of this direction. First of all, when I deep in this direction, I read a beautiful book from academician Yershov and Professor Samokhvalov. It's about task approach, where they formalize theory of task approach and define some definitions. What does it mean, task? When we can say that task is definable, and so, etc., etc. First of all, I would like to note that when we say about task, we will fix some domain. And in our theory, our domain, it's a hereditary finite list superstructure, which will be p-computable and has some basic list operation. If there exist some prior elements, it's a simple elements, for example, natural numbers, but we can construct on these numbers hereditary finite lists. It's a list consists from these natural numbers of elements, and by induction we can construct these complex and complex elements. And any task we can formulate on delta zero using delta zero formulas or sigma formulas. If we can formulate our task in delta zero formulas using a boundaries quantify with list relation, we can guarantee we can find solution in polynomial time. It's very important for artificial intelligence because guarantee that some program will finish own execution in polynomial time. We guarantee that artificial intelligence system will be work reliably. Then Yershov and Samokhvalov says a problem is defined if and only if the criteria for its solution defined. Then we create a p-complete languages. It's languages, logical languages, where we find some syntactic construction and we extend our base languages L such that final extension of these languages will be equal of P. P is the class of all polynomial algorithm. That means any algorithm we can define, we can impress using some program from our languages. And another side, for any program from our languages has polynomial computable complexity. And these are main theorems in mathematics. I think it's these theorems we only find some solutions. I think this theorem have a more powerful future because we don't understand all directions where we can define this theorem right now. But where we find this, it's impressive because, for example, right now we decide a problem P equal L. We find some syntactic constructions which allow us to guarantee that our languages not exceed a class of all polynomial algorithms. And we find some extensions of Gandhi fixed point theorem. It's one of the main theorems in the logic. When we can define some recursive construction and guarantee that, for example, it's last result about recursive function, that this complexity don't exceed a polynomial. We find some boundaries when this complexity is very good. But because in common sense, recursive functions exceed polynomial complexity. It may be exponential complexity or other and other. Okay. For example, what does that mean, Gandhi fixed? There is some base element on each iteration we can construct more complex and complex element, and on omega and omega steps we can construct some operator which have on omega steps a fixed point. All of this set of elements is a fixed point for some operator. It's very important, and we prove that this fixed point will be pre-computable for the set. We also prove that for the function, when we have a partial function on our elements, and we by iteration define a new values of this function by iterative process. Okay, it's a programming. Yes, we construct a programming methodology. We can use any Turing complete languages, and we can analyze what this program good for us or not good. If this program is consistent with our methodology, we can say that this program will stop, because in common sense this program has a Turing halting problem. Okay, and about task approach, I can say it about this. When we formulate a task, we can formulate acknowledge. What that means, acknowledge probabilistic. When is a triple. When we formulate a task, we find a solution, and we have a probability of this solution. What's the meaning of criteria of solution of the task? That means if we substitute for y term t from x, we can guarantee with probability p this formula will be true. This predicate which define probability of the truth of the formula, I can skip because we have not sufficient time. Then we can create hierarchical structure of the probability knowledge, and we can solve our task using hierarchical model on this knowledge, and we can find best solutions. Our main theorem states that if we have some knowledge base, we have some incoming task, we can find this best solution for polynomial time. It's an alternative method for learning, but we can combine with the large languages model, because right now we have some papers where we send some task on solution to large languages model on outsource, but if large languages model decides this task, we can check using our logical methods, correct this task or not correct. And we spent smaller computation complexity, because check correctness of solution, computation complexity smaller than find this solution. For example, it's a NP complete task. Find solution is very complex, but check solution we can in polynomial time. Все?
Polynomial time.
Okay, 2 minutes please, and I will finish. I see we get some time from. Okay, many works in this direction. It's only selected works about task approach. Then there is a practical realization. I would like to notice that we have a trilemma of blockchain. Why we use a multi-blockchain system? Because we cannot reach these 3 high-value parameters for one blockchain. We will reach only 2, for example, security and scalability, or security decentralization on only one blockchain. If we use a multi-blockchain structure, we can share these values. For example, top-level blockchain have max decentralization and security. Low-level blockchains, for example, we can use for scalability. This work from 2017 with Uzbekistan researcher. he went to our institute, Sobolev Institute, and we make short paper where this a situation using multi-blockchain in smart city. How we can use for any edge device, we can create own blockchain, but using a hash, we can store it this on the top and top blockchains, and we can use AI technologies for analyzing this information, because this information can be very big. Right now, I think our prospects, it's a combination, it's a hybrid AI. When we use large languages model, we combine this with logical probability approaches, and we use a multi-blockchain systems for guarantee of transparency, reliability, and etc. parameters. Thank you for your attention. Thank you. If you have a question, you can ask me on the break. Okay. I think on the break, or maybe you have one question you can ask right now.
Yeah, perhaps I have something.
Yeah, of course. Please, one question there. Oh, Nish.
Yeah, I think it's a really very important case of connection between the intensive work in mathematics and in mathematical theory of algorithms, which was going in our country and in Novosibirsk specifically for last years. And I would like just to indicate perhaps not a question for longer discussion now. Perhaps I will even touch in my own talk after the break. But the question is that all these things which were said about the polynomial time looks very kind of usual and classical.
Yeah.
But in the case of artificial intelligence, we have different kind of scales, different sizes.
Yeah.
For example, you can consider the amount of data, which is in terabytes and whatever. And then you have a polynomial, say, in the, it's like cubic polynomial.
Yeah.
What will it mean? So, I mean, we should come and transform complexity theory and all these quantifier hierarchies in the case of real sizes of data which are exploiting now. So perhaps it's a field for the future research. Will be very interesting. Starting with polynomials, but polynomials now means a little bit different story than before. Okay, thank you.
Okay, thank you. Yes, of course, I want to notice that we can share our task on the complexity, because we understand which task we send a large languages model, which complexity when we use this, because it's very important. It's for this direction depend how long artificial intelligence will be execute this task, and etc. Thank you. We go on the coffee break. Thank you very much.
Сколько минут?
Часа пол, да?
Давайте 15 минут все-таки. У нас здесь все. У нас просто
Не, я чтобы мы все могли. Я могу и не пить кофе.
Общий или каждый сам?
Здесь прямо. Здесь никуда не идем, просто здесь. Нет, 2 часа-то...
Так все-таки обед когда будет?
12:30 начало,
Значит, у нас обед 12:30? В смысле не здесь, а там будут нас кормить?
Обязан начаться.
Обед? Нет, я понимаю, но...
Они, я думаю, кормят вас.
Нет, то есть гостиничный
Если вы пойдете, вас
открыт.
Ресторан 12:30 открыт.
Да, понятно. Все, спасибо.
Он весь день открыт.
Кто-то подошел, да?
Раньше был открыт, сейчас я могу вообще слушаю, потому что у них там постоянно какие-то...
Да, я вижу. Может быть, вы узнаете, будет ли... Потому что народ припрется, будет там непонятно, что делать.